Hi everyone, Mrs. V here, and today we are going to look at the steps required in calculations for a basic titration. This is the titration between a standard solution of sodium carbonate and an unknown concentration hydrochloric acid. This is quite a common first titration, so let's get the whiteboard on and look at what to do with your results. In this titration, we are going to be looking at standardizing a hydrochloric acid solution using a sodium carbonate solution. So we know our hydrochloric acid is approximately 0.1 moles per litre. So we're going to make up a 0.05 moles per litre sodium carbonate solution. We need the sodium carbonate solution to be about half as concentrated as the acid. And that's because when we write the equation for the reaction, we see that there's a 2-to-1 mole ratio between the hydrochloric acid and the sodium carbonate. So keeping the concentration of the sodium carbonate around about half that of the acid is going to lead us to have a titer that's approximately equal to the aliquot, which is what you measure out with the pipette. So we've talked about how to go about doing this. You're going to make up a standard solution. Okay, so you're going to use a 100 ml volumetric flask, and we're going to dissolve sodium carbonate in water to make up this standard solution. So the first thing you're going to need to do is calculate how much sodium carbonate you are going to need to weigh out so that you can make your solution. So let's start with that calculation. Now, the molar mass of sodium carbonate is 105.99 grams per mole. You might like to write grams per mole like this. It doesn't really matter. Okay, so we're going to first of all work out the number of moles. So we're going to be working with this 100 ml volumetric flask. So that means our volume is going to be equal to 0.1000 litres. Let's work out our moles. So we want concentration to be equal to 0.05 moles per litre. We're not worrying about significant figures at this stage because we haven't made any measurements, so we're really not bound by significant figures. Isn't it pleasant to have a situation where you don't have to stress about significant figures? Okay, our volume is equal to 100 mils. So our moles, we can calculate concentration times volume, which is 0.05 times by 0.1000. Don't lose the zeros on the end there. You don't want to lose the number of significant figures generally, so it's always a good idea to just practice keeping them there. So this is obviously 0.005 moles. Now it's a matter of converting that to a mass. So we know that mass is equal to moles times by molar mass. So here we've got 0.005 moles times by 105.99. So the mass we're going to need to weigh out is around about 0.53 grams. And so my balance weighs out to 2 decimal places, which is why I've expressed my mass there to 2 decimal places. But I don't need to weigh out exactly 0.53 grams. I just need it to be in that range. It's just important to know exactly how much that I have weighed out. So you don't have to actually just sprinkle tiny bits of sodium carbonate until you've got the perfect 0.53 grams. You're just going to waste a lot of time. If you're in class, there's probably a lineup for using the balance. You're just going to annoy people who are behind you in that line by taking too much time. So I went to the balance and I weighed out 0.54 grams. I wasn't going to scoop a bit out and then sprinkle a little bit back on until it was perfect. 0.54 is close enough. The main thing is I know it's 0.54 because I'm going to need to use that in my calculations. Then, of course, I placed the solid in my volumetric flask. I added some distilled water, shook it up to dissolve it, topped up the flask until the bottom of the meniscus was on the calibration mark. Very important that the bottom of the meniscus rests exactly on the mark. If it's just under, you're in luck. You can add another drop of water. If it's just over, you must start again with making your back to the balance. To weigh some more out, you need to rinse your flask out. It's just a disaster. So make sure that when you do that final addition to your volumetric flask, that you use a dropper to just go drop by drop by drop, and so that you can get that bottom of the meniscus exactly on the mark. Okay, so I've done that. I've put the stopper on, inverted it several times so it's of even concentration. But now I need to actually do the calculation to work out exactly what the concentration is of that solution. Okay, so you need to now pretty much do the calculation we just did, but in reverse. So here I now know my mass of sodium carbonate is 0.54 grams. Now that is my measurement, so I am actually bound to two significant figures now. Okay, because I've made a measurement and my measurement has two significant figures, so I can get no more precise than that. So I'm going to now convert that to moles. So my moles of sodium carbonate, I'm going to do that by mass over molar mass. So 0.54 over 105.99. And when I run that through the calculator, I get 5.1 times 10 to the minus 3 moles. Now that's how many moles of sodium carbonate I tipped into that flask. So I can work out its concentration now because I know the volume of the solution is 100.0 mils. So I can now work out my concentration. Concentration is moles over volume. Remember, the volume has to be in litres. My moles is 5.1 times 10 to the minus 3. And my volume is 0.1000 litres. So I know now that my concentration is equal to 5.1 times by 10 to the minus 2 moles per litre. From here, we are going to go into our next phase of standardising the hydrochloric acid, which is actually performing the titration. But that is a topic for our next video. I will see you then.